Hey everyone, welcome to Cassandra Lunch. We'll give everyone a couple more minutes to file in and we'll get started soon shortly. All right, we'll give everyone another minute or so to file in and we'll get started soon. And while you're here waiting in the chat before we start, don't forget to like and subscribe while you're here. It helps us out and also um, can help us show what topics people like. So feel free to drop a like and subscribe. You can also turn on the notification bell so that way you get notified every time we post a new video or if we post a new post in the community section or whenever we go live for a talk. Alrighty, let's go ahead and get started. Hey everyone, welcome to Cassandra Lunch number 118. Today's topic is going to be on Yugabyte, Spark, and Airflow. We are going to focus on Yugabyte in the context of Cassandra, right? This is a Cassandra launch. I will be the speaker for today. My name is Arpan Patel. I'm an engineer here at Anant. Co-organizers for this event are Rahul and myself. If you are interested in giving a talk here at Cassandra Lunch or our sister lunch, Data Engineers Lunch, feel free to reach out to me. My email is listed below. You can always drop a comment on the YouTube channel as well. Also, we're looking for sponsors. So if you're interested in sponsoring Cassandra Lunch or Data Engineers Lunch, feel free to reach out to me. We are a part of Data Community DC. So Data Community DC believes in building an inclusive environment. So no matter your race, gender, or sexual orientation, everyone is welcome and we expect the respect to be given to all. Data Community DC is built of a bunch of different organizations. Our sister lunch, Data Engineers Lunch, falls under Data Wranglers DC. So if you're interested in all the various events and groups that fall under the umbrella of Data Community DC, you can find out more at datacommunitydc.org. So what do we cover here at Cassandra Launch? We cover everything that is Cassandra, talks Cassandra, or plays well with Cassandra in the ecosystem. So whether that be open source Cassandra, Yugabyte, which we'll be using today, Scylla, DataStax, whether they're also the open source or managed enterprise, et cetera, and as well as things in the ecosystem like Spark, Kafka, Airflow, like we'll be using today. So if anyone's new here in the YouTube chat, say hi, hello. What do you do with Cassandra? Group rules, if you have a question, ask it. Feel free to drop comments or questions in the YouTube chat. And I have the chat pulled up here, so I'll be able to respond to them as they come in. And obviously, please be polite and courteous to others. And please do share what you know with us. This is meant to be a community. So the more you know, the more everyone will know. Here at Anant, we design, build, and manage global real-time data analytics platforms surrounding Cassandra, Spark, and Kafka. So Cassandra is our bread and butter. GW University helps provide venue space when we have in-person events. We also have some organizational and institutional sponsors. If anyone is looking for a job or has any jobs to offer, feel free to drop links in the YouTube chat, as well as if they have any meetups, hackathons, conferences, classes that they would like to promote, feel free to drop those in the chat as well. Anant is hiring full-time, part-time positions, data platform operators, engineers, and architects. You can find out more at careers.anant.us. Upcoming events, you can check out our events page, anant.us/events. Data Engineers Lunches happen every Monday. On this upcoming Monday, we have a guest speaker, Will Angel, who will be talking about governance. So if you're interested in that, you can find out more on our events page, and as well as Cassandra Lunches, which happen on Thursdays at 12 p.m. Eastern as well. All these videos are available on our YouTube channel, youtube.com/AnantCorp, under the playlist of Cassandra Lunch, but as well as on the main channel. And so you can find everything from Cassandra Lunch 10 to today, which is 118. Cassandra.Link should be your number one resource for all things Cassandra. This site is powered by hand-curated articles, videos, news feeds by the team here at Anant, and feel free to check it out. We've also released our 9th free Apache Cassandra runbook. This one covers getting started with Cassandra troubleshooting, as well as starting, restarting, debugging, down nodes essentially. So we'll give you some tips and tricks and some easy commands to run, as well as some methods to diagnose why your node tool status is showing down normal, right? And with that, we'll go ahead and move over to the portion for today's talk. Alrighty. So as mentioned before, today's talk is going to be on Yugabyte, Spark, and Airflow. So what we're going to do here today is we are going to use Yugabyte, and we're going to run some Spark jobs against it while all orchestrated by Airflow, right? And so we're going to be looking at Yugabyte today in the context of Cassandra, and we won't go super in depth about Yugabyte. It's a very it's open source, right? They have an open source level, and so there's a lot you can learn about Yugabyte and a lot you can do with it. So if you're interested in that, our last video from Friday, where we had a talk in partnership with Yugabyte, Peter from Yugabyte helps provide some introduction and some more context about what Yugabyte is, what you can do with it as well. So feel free to check out that as well. But today we're just going to focus on top level, just what is Yugabyte, right? So it's an open source distributed SQL database, right? They also have a managed option, which has a free no credit card tier. And we'll talk about that once we get to the demo portion. And then they also have a self-hosted DBaaS, so kind of like BYOC. And then they have some documentation about how it compares to Cassandra. You can find that on their website. It's also linked here. And also some more information about their YCQL API, which is what we're going to be focusing on today specifically. They have a YSQL API and they have a YCQL API. And right, because today is Cassandra Lunch, we're going to be focusing on the YCQL API, right? So if you're not familiar with the YCQL API, it's a semi-relational SQL API. It has roots in CQL, so a lot of the context and commands you run are CQL, like a C as in the letter C. And it supports strongly consistent secondary indexes. It has native JSON column type support. So like if you're familiar with JSON-B, as well as like distributed transactions, right? And so one of the main things we'll be using today for the demo, especially if you're working with Cassandra workloads, Yugabyte has its own fork of the Spark Cassandra connector, which is put out by DataStax, right? So what we'll be working with in our app, in our DAG, is going to be the Yugabyte version of the Spark Cassandra connector, because we're going to be using Yugabyte as our backend, and that's how we're going to talk to it with Airflow and Spark, right? So for the demo portion, all of this is going to be done on Gitpod. And so I'll drop the link to it in the YouTube chat in a second, but essentially it's a one-click, everyone can do it. You can do it on your computer, you can do it on your tablet, et cetera, et cetera. And then the README has all the steps that you need, and we'll go through that. I'll literally just be copying and pasting from the README for the commands. So the idea is we're going to be starting up Yugabyte, starting up Spark, and we're going to be starting up Airflow. We're going to run a DAG, which runs two quote unquote ETL jobs. So the first one is just going to be an E&L, which is extract and load. And then the second job will be an actual extract, transform, and then load, right? And we'll talk about the actual functionality of it once we get to the actual demo portion. But one thing to note is that we'll talk about a couple of issues that I face. Some of them might be more Gitpod related, but one of the other things is that when you're using Yugabyte managed service, so kind of like Scylla Cloud or DataStax Astra comparison, right? It's free, no credit card required. However, when you're trying to talk to it from like your local computer, you need to whitelist the IP address. So like, for example, DataStax Astra has a secure connect bundle, right? So when we're using something like Gitpod, which is just a Docker on Kubernetes that we get for free, right? It's harder to get that IP address from the Gitpod container to talk to Yugabyte managed. So what I had done is, instead of using Yugabyte managed, we're going to use Dockerized Yugabyte. And so that way we can run Docker on Gitpod. So we have Yugabyte just via Docker instead of managed. I would have liked to use managed Yugabyte, but until I figure out how to get the Yugabyte to whitelist the Gitpod IP, we'll just work with Docker for now. And then one of the other issues I noticed was with it's more of a Spark 3.3 issue. And so that's related to like essentially Cassandra writes. So because again, we're going to be using the Yugabyte Spark Cassandra connector fork when it tries to write using Spark 3.3, because there is a version of the Yugabyte Spark Cassandra connector that supports Spark 3.3. But there is something in Spark 3.3 that it doesn't like doing writes. So I had downgraded to Spark 3.2, and so that resolved that issue. And there was one more issue that, again, is more Gitpod related, but you probably won't face this in the real world or your local computer if you choose to do it this way. But it's essentially, I ran into some weird O31 load issues when trying to essentially do that first DAG task, which is the extract and load. And so for whatever reason, whenever like I tried to run the spark.read and then load into a data frame, it was just not liking it. So what I had to do was then use OS and sys to add the path to whatever Spark version we're using to path, and that helped resolve that issue. So we'll talk about that once we get this spun up, but just wanted to put it out there. However, if you do want to use Yugabyte managed to do a demo or whatever, there's a repo and a blog post by Yugabyte as well, where they show you how you can use your local and point it to Yugabyte Cloud. They'll show you how to whitelist, etc. And they use Spark Shell primarily in their demo, but today we're going to be using Spark Submit and PySpark specifically, just because when you're using Scala, you have to build the jar and then you have to pass that to Spark, right? And so for this, just for ease of use and ease of replicability by anyone who uses this, we're just going to be using PySpark. The nice thing about the Airflow Spark operator is that you can either pass in a jar or you can pass in a Python file, right? So we're going to be using that. And with that, what I'll do here first is drop this link to the repo that we're going to be doing. And so what I'm going to do is just spin this up in Gitpod. And while that's spinning up, we'll take a look at what's in here, right? So we have that Spark 3.2 that I was talking about. We have the first ETL Pi. So that's our first, or that's technically our second PySpark job. Our first PySpark job is the extract and load. And so what that's going to do is essentially it's going to take 100,000 rows from the CSV here, and it's going to load it into Yugabyte. And so if we take a look at this here, it's a very simple Spark job, right? It just says read format option load. And so again, here's where we ran into that weird O31 load. It didn't like it. But essentially we pointed to the path of the CSV, we select the columns we want, and we write that into Yugabyte. But if you notice this, we're using the Cassandra format, right? And so that's where the Yugabyte CQL API comes into play, right? So we're able to still run our Cassandra workloads, but then push it to a distributed SQL database, right? So if you want to learn more about the Yugabyte architecture, feel free to check out our video that we did in partnership with Yugabyte, but as well as you can check out their documentation, because we are using an open source Docker container or a Docker container of open source Yugabyte, right? So that is the first job we're going to be running. And then the second job we're going to be running is extract and load, but it's essentially going to be extracting from that data, that table that we loaded into. We are going to transform some of the data, which here, so our dummy data is just CSV generated, job title, employee ID, employee name. And then we have the last day that they worked and then the first day that they worked. But because these are generated data, sometimes the last day finishes before the first day starts. And so what we're doing here is just, we're going to run the date diff. So we're going to calculate the difference between the start day and date, last day. And that's going to generate the amount of days worked between that duration, right? And we're just going to take the absolute value. So that way, even though it's just going to be a subtraction, we can get a positive number outside of it. And then we're going to load that into a second table that we also create. And so before we get to the DAG, we'll just go ahead and quickly start going through the steps here. So let's go to my README. So the first thing we're going to do is we're going to start up Yugabyte. And so what we're going to do here is we are going to run our Docker container. We're going to expose a couple different ports, right? So Yugabyte has two UIs, right? So there's like the T server and master servers. We're just going to be using port 9000 for the server because we can see our user generated tables. And then we also have 9042, which is our Cassandra port, right? And then there's also 5433, which is for their Postgres YSQL API aspect of it, right? This won't take very long, but again, if you have any questions or comments, feel free to drop them in the YouTube chat. Don't see any more questions at this time, but now while this is loading, let's take a look back at the DAG itself. So what we're gonna be doing in the DAG is we are going to import our Spark Submit operator, and this is all done in the setup script, and we'll take a look at that in a second, but that's essentially just the setup script that Airflow provides you. But essentially here, again, as mentioned, this OS environment and syspath append, this is to help resolve this weird Java error that I was getting, 032 load errors. So this may not apply if you're running this on a different machine. This might just be a Git pod thing. So just keep that in mind. But essentially what we're doing here is we have a dictionary which defines our, essentially, it's a replacement for a properties file, because when you're using the Spark Submit operator, you don't pass in a properties file. You have a conf parameter, which takes a dictionary. So what we're going to be doing is just passing in some extensions. We're going to pass in our key space name, and we are going to also pass in our Cassandra connection host. But again, this is going to be Yugabyte, and it's going to be running on Docker. So we can just say it's local 127.0.0.1, right? So the first task in this DAG is going to be a load and write job, which we took a look at, right? Our extract and load. And this is going to take in our job configuration dictionary. And then we're also going to pack in our packet, or pass in our package, right? So as mentioned, the Yugabyte version of the Spark Cassandra connector, we're going to be using the Scala 212, and then we're going to be using the Spark 3.2 YB2. So they have a couple different releases. So they also have YB1, I think for their Spark 2.4 connector, they have like 8, like it goes up to YB8. But again, you can just check out their Maven coordinates and then it's all listed there. But because we're using Spark 3.2, we just want to make sure it matches, right? And so that's all we need to do for the Spark Submit operator. Essentially, again, it's the same thing for the second job, but just our application jar or PySpark file are the differences, right? And then we just have a dependency here, which will load and write into the first table. And then the second job will take data from that, do some transformations, write it into the second table, right? So now that our Yugabyte is up, what we are going to do is just pull up the UI. I'm just gonna make this public real quick, And again, as mentioned, we're just gonna look at the 9000 UI. There's also the, actually, sorry, let me go back. We wanna open the 7000 UI. And this will show us where our tables are. So we see user tables, right? Currently we have no user tables. Let me just pop over, see if there's any questions. Nope. Okay. So the next thing we're going to do here is, now that our Yugabyte's up, we can actually run a command to essentially create our tables using Yugabyte YCQLSH, right? So if you're familiar with Cassandra, you have CQLSH. Yugabyte has YCQLSH. And so we have this setup SQL file, which essentially just is our two, it creates our key space, and then it also creates our two tables. So this is the first table, which is just previous employees by job title, which has the first table. And then the second table, which is days worked, which is where we're going to calculate it from the first table and put it into the second table. So now that this command's been completed, if we actually go back to the Yugabyte UI and we refresh, we now see our two tables that we created, and we see that under user tables, right? We can also see a little bit more metrics here as well. So the next thing we're going to do is we are going to start up Airflow. So we're going to run setup.sh. So if you're familiar with Airflow, if you've ever run it on your local, this is essentially their instantiation script that they give you. But we do have some modifications that we made to it, which are related to, we're also installing the Apache Spark operator. And then we're also creating a user. I believe in their scripts, they have Airflow DB, or after Airflow DB init, they have like another command, which brings up scheduler and Airflow for you. But because we're also going to be starting up Spark, and we're also going to be starting up, we also just want to add a password to our user so they're having to search for it. We're just adding it manually here. But because Airflow Spark 3.2 runs on port 8080, we just swapped the Airflow UI to 8181 instead of the normal 8080, right? All right, and so this should finish up in a minute. And so while this is happening, I will peek over to see if there's any questions. No questions so far. All right, so it looks like Airflow has started. If you just open up a new Bash terminal, we are going to also pull up our Airflow UI on 8181. And we are running Airflow 2.4.1, which I believe is the latest. And so next thing we want to do is we want to move our DAG into the DAGs folder, but we need to create that DAGs folder first. And now that that's happened, our file's gone. And so because the default Airflow scheduler, I think, reads every 5 minutes, while we're waiting on the DAG to show up in the UI, we are going to go ahead and start up our Spark, right? So this won't take very long at all, but what we're going to do is just start the master. And then once the master pops up, again, it's going to be running on 8080. So we're just going to open this up, and then we are going to copy this URL, and we are going to start our worker. Okay. And so once the worker is up, if we do a quick refresh here, we now see our worker up, right? So we also need to establish our Spark default connection in Airflow. So we can just go to Airflow connections, just search for Spark, edit, and we can paste this into the host. You can leave it as is. You can leave the port here, or if you want, you can move the 7077 down here, but you don't need to do it. So we're going to go ahead and save that. And let's take a quick peek and see if our DAG is now here. Yugabyte, nope, it is not here yet. So while we wait on that, what we can do is just do a quick select statement from our first table, which is going to be running our first extract and load task. And so when we run this command, we should get back 0 rows, and we do, right? All right. Let's give this a quick refresh. Let's see if our Yugabyte has shown up yet. Nope. Okay, while we're waiting on this, let's open up the floor to any questions. And while you're dropping any questions as well, to talk about why we're using also Spark 3.2 to give the exact error I had received. It was unsupported data source v2 partitioning type Cassandra partitioning when using Spark 3.3. So that's why we dropped it down to Spark 3.2. And so that's just something to keep in mind when you're using the Yugabyte Spark Cassandra connector, as well as just Spark and Airflow and Yugabyte / Cassandra in general. All right, so let's give this another refresh. Okay, so while we're still waiting on this, what I do want to talk about is if you want to do this with Yugabyte managed, they have, like, again, they're using a Scala, and you see this namespace.sql. A namespace in Yugabyte correlates in Cassandra terms as a key space, so that's the connection there. And so they have a Scala file. Again, we're going to be using Python and PySpark just to make it easy so you don't have to compile anything. But essentially what they're doing here in this application is that first they download some Yugabyte stuff. They create, and again, they give you a root CRT file. So you'll need to create a key using key tool. So that way you can then talk to Yugabyte managed. They give you some instructions how to do it here, and how you can use YCQLSH as well to talk to it as well. So you don't have to run your Spark job or Spark shell just to confirm the connection. But essentially what they're doing here in this specific example, they're using Spark 3.03, and then they're using their Cassandra connector 3.0-YB-8. Again, this is like version 8 of this specific Yugabyte Spark Cassandra connector. And so if you look here, pretty much looks pretty familiar for working with it. There are some steps that just looking at this code, there's parts where they can not repeat themselves, but at the very least, they show how you can set your local DC. So when you're using Yugabyte managed, they actually give you instructions of how to talk to it with like a CQLSH or if you're using Spark in the documentation, but specifically in Yugabyte managed, they tell you what your database ID is and the location of it. So what you'll need to do when setting your connection, you'll also need to use local DC. So that is something to keep in mind. Host, this is just for that. But yeah, so again, if you're using Yugabyte managed, you'll need to be using the SSL stuff and then pointing to your trust store and your key stores, etc., with username passwords as needed. But again, for the most part, you can follow along with this demo. It's available in the resources section of this slide deck, which will be available after this talk. We'll drop the link to the SlideShare in the YouTube description. All right, let's see if our DAG is now finally here. Okay, our DAG is finally here. So as mentioned, if we look at the code, what we're going to be doing is we're going to be running two tasks. First one is going to extract and load into a single table. And then the second task is going to grab data from that table, make some transformations, and write it into the second table. So the first thing we're going to do is we are going to turn this on, and we are going to trigger it. All right. And so while this is waiting, again, if you run into any errors while doing this, just remember you need to set up your connection to Spark so Airflow knows where to point the job, where to trigger the Spark job to, and where on what cluster to run it on, etc. So we see the first job is now running, and we'll just take a look in the graph view. All right, and so while this is happening, we'll go back to our Git pod, and we'll just rerun this command just to see if some data is coming in. Okay, no data yet, but actually this is doing a where clause. So if we want to do a select count, that would be more accurate. So let's just do a select count if we just want to see arbitrary data coming in. All right, so we see 6,000. So again, the CSV that we have on the GitHub repo is 100,000. So this won't take very long, but we'll just track it as it's going. So it's already done. So while this is done, we should now be able to go back and see that the first job has completed. All right, first job is completed, and now we're waiting on the second job to run. So if we go back to our Git pod and we rerun the select all where it is a dentist, so we see some data, right? We see job type, employee ID, employee name, and then we see their start date and end date. So this specific person started in May of 2000 and ended in May of 2020. So it's about 13 years, right? So what is 365 times 13? So that's about 4745, right? So about 4750, right? So let's now check our Airflow and just do a quick refresh. And we see now our second job has also completed. So our DAG has completed both tasks successfully, right? So now if we go back and we grab our second select statement, So if we look at this date here, for this specific person, their days worked that was calculated by our Spark SQL statement should be 4750-ish, right? Granted, there's some, we're not being very specific with what type of, we're not doing any typecasting to like cast it as a float. But for the most part, we're just letting Spark SQL handle that. So when we run this, if we look at Percy Bowen, we see 4747, which I think is 2 days off the 365 times 13, which actually makes sense because they started on May 3rd over May 5th, right? So -2, so or +2, because the 5th is after the 3rd. Sorry. Yeah, so it's 13 years and 2 days. But yeah, so the math adds up. So obviously we're taking this with a grain of salt in terms of the actual computations that are happening. But at the very least, we're able to use Yugabyte as our backend, use the CQL API as well as YSQLSH or CQLSH, and still run the same workload. So if you're familiar with, and if you've been here for any of my previous talks, you might recognize this code, right? So it's pretty much the same thing I did with Cassandra, but I was pretty easily able to switch it to then use with Yugabyte. So yeah, if you're working with Cassandra workloads and you want to add some workloads to Yugabyte, or you want to switch over in general, this could be a starting point of how you can play around with it. But yeah, this will wrap up my demo portion of today, and we will open up the floor to any questions. So feel free to drop them in the YouTube chat. I'm monitoring it here. And again, if you're watching this, don't forget to like and subscribe and turn on the notification bell so that way you get notified every time we go live and every time we post a new video, etc. But it doesn't look like there's any more new questions. So we will go ahead and wrap it up for today. Thank you everyone for joining us here for Cassandra Lunch. Again, next week, next Monday, we have a guest speaker, Will Angel, who's going to be talking about data governance. So if you're interested in that for Data Engineers Lunch, feel free to check it out, as well as catch us next week here, same time, same place for Cassandra Lunch. And with that, we'll go ahead and wrap it up for today. Thank you everyone for joining us, and we'll see everyone next week. Take care.